To solve an equation containing one radical, we will isolate the radical on one side of the equation. Then we're going to raise both sides of the equation to the power of the index. This will undo the radical. Then we'll solve the resulting equation and check our solutions. So for the first example, we have the square root of the quantity x plus 6 equals x plus 4. Notice how the square root is isolated on the left side of the equation. And because we have a square root, the index is 2, so we're going to square both sides of the equation. Notice on the right we're squaring the entire side, we're not squaring each term. So when we square the square root of x plus 6, this will simplify to the radicand of x plus 6. And then for the right side we have the quantity x plus 4 times the quantity x plus 4. So now we need to multiply this out, and we'll have 4 products. 1, 2, 3, and 4. So we'll have x plus 6 equals x times x, that's x squared. Then we're going to have x times 4, that's 4x. But notice how the next product is also 4x. So we'll have a total of 8x. And then 4 times 4 for plus 16. So now we have a quadratic equation that we need to solve. So we'll set this equal to 0 and see if it factors. So to set it equal to 0, because we have the squared term on the right side, we'll subtract x on both sides, as well as subtract 6 on both sides. So we'll have a 0 on the left side equals x squared. This will be plus 7x, and this will be plus 10. So this is factorable. This will factor into 2 binomial factors, where the first terms will be the factors of x squared, which will be x and x. And now we want the factors of positive 10 that add to positive 7, which would be 5 and 2, so we'll have x plus 5 and x plus 2. So this product will be 0 when x plus 5 equals 0, or x plus 2 equals 0. So we have x equals negative 5, or x equals negative 2. And now to check these, we'll sub them back into the original equation to make sure they actually work. So when x is negative 5, notice how we'd have the square root of negative 5 plus 6, that would be the square root of 1, equals, on the right side we have negative 5 plus 4, which is equal to negative 1. Well, the square root of 1 is not equal to negative 1, and therefore x equals negative 5 is not a solution. This is called an extraneous solution, one that we found algebraically but does not work. Now we'll check x equals negative 2. Well, if x is negative 2, we'd have the square root of negative 2 plus 6. That would be the square root of 4, equals, on the right side we'd have negative 2 plus 4, which is equal to 2, which is true, and therefore our solution is x equals negative 2. So we only have one solution, even though algebraically it appeared that we had 2. This is the main reason why it's so important to check our solutions when solving radical equations. Let's take a look at our second example on the next slide. We want to isolate the square root of the quantity 4x plus 9. So the first step here is going to be to undo this minus 1 by adding 1 to both sides of the equation. So we'll have the square root of 4x plus 9 equals x plus 1. And now because we have a square root with an index of 2, to undo this square root, we'll square both sides of the equation. So on the left side we just have 4x plus 9, and on the right side we have the quantity x plus 1 times the quantity x plus 1. So now we'll multiply this out. So we'll have 4x plus 9 equals, again here we're going to have 4 products, 1, 2, 3, 4. So we'll have x times x, that's x squared. X times 1, that's 1x. And 1 times x is also 1x, so we have plus 2x. And 1 times 1 equals 1. So again we have a quadratic equation So we'll set this equal to 0 and solve for x. So we'll have to subtract 4x on both sides, and also subtract 9 on both sides. So we'll have 0 equals x squared. This will be minus 2x, and this will be minus 8. Let's go ahead and solve this over here on the left. Let's see if it's going to factor. First terms will be x and x, and now we want the factors of negative 8 that add to negative 2. That'll be a negative 4 and a positive 2, so we'll have x minus 4 and x plus 2. So this product is equal to 0 when x minus 4 is equal to 0, or when x plus 2 is equal to 0. So here we have a solution of x equals 4 or x equals negative 2. But now we need to check these to make sure they actually work. So to check x equals 4, we'll substitute 4 for x. So we'll have the square root of 4 times 4, it's 16 plus 9. That would be the square root of 25 minus 1 equals 4. Well, this would be 5 minus 1 equals 4, which is true, so x equals 4 is a solution. And now we'll check x equals negative 2. So if x is negative 2, we'd have the square root of 4 times negative 2, that's negative 8 plus 9, that's the square root of 1, minus 1 equals negative 2. Well, this would be 1 minus 1, or 0. 0 doesn't equal negative 2, so x equals negative 2 is not a solution. It's called an extraneous solution. So we do only have one solution to this equation. It is x equals 4. I hope you found this helpful.